All right, let's get right into it. Something pretty incredible is about to happen up in our night sky. I'm talking about an event so rare that for most of us, this is a true once-in-a-lifetime chance to see it. What is it? Well, we're talking about a star that's about to explode. And I know what that sounds like. But this is not science fiction. A star that is, for all practical purposes, dead, is about to come roaring back to life. It's this amazing cosmic cycle of death and rebirth that plays out on a timescale just way bigger than our own. So, what are we actually looking at here? Well, the star system we're talking about is called T Coronae Borealis. It's located in the constellation Coronae Borealis, which is just a fancy way of saying the Northern Crown. And get this, it's about 2,600 light years away. So the explosion we're about to see, it actually happened 2,600 years ago. We're just now getting the light from it. Kind of mind-blowing, right? And this really captures what it must have been like for people centuries ago. If you didn't know it was there, and then one night, bam, it explodes, you just say, whoa, there's a new star in the sky. And that very illusion, that's actually what gave this kind of cosmic event its name. Yep, nova is literally just Latin for new. But as we're about to find out, there is nothing new about this star at all. In fact, it's part of a really old, really dramatic, and, let's be honest, a pretty destructive partnership. Okay, so what is really going on? To get it, you've got to meet the two main characters in this cosmic drama. We've got what you might call a stellar vampire, and its bloated victim. First up, we have our vampire, a white dwarf. Now, this thing is the dead core of a star. It's incredibly dense. We're talking about something the size of Earth, but way, way heavier. It's just glowing from leftover heat. And fun fact, in about 5 billion years, our own sun, it's going to become one of these. But this particular white dwarf, it isn't alone. Its partner in crime is a red giant. This is an old, aging star that's just swelled up, becoming totally enormous and kind of puffy. Its outer layers of gas are so spread out that its own gravity has a really hard time holding on to them. You can probably see where this is going. And here's how the cosmic crime goes down. Step 1, the red giant puffs up, and its gas gets a little too close to its neighbor. Step 2, the super dense white dwarf's gravity is like a vacuum cleaner, and it starts pulling all that gas onto its own surface. Step 3, that stolen gas just piles up, and as it gets deeper, the pressure and the temperature at the bottom just skyrocket. Finally, step 4, it reaches a tipping point. The pressure gets so intense, it triggers a massive thermonuclear explosion, blowing that entire layer of gas right off into space. And that huge blast, that's the nova we see from Earth. But here's the really wild part. This isn't a one-and-done deal. Oh no. After that massive explosion, the whole process just starts over. Again and again, like a perfectly timed cosmic clock. For this particular system, T Coronae Borealis, the whole cycle takes about 80 years. Once the explosion clears the deck, our little white dwarf vampire just goes right back to work, slowly siphoning more material off its red giant buddy. For 80 years, it collects that gas until the pressure hits that critical point again, and boom, another nova. So how can we be so sure this has happened before? Well, when astronomers point our most powerful telescopes at this system, they can see these faint, almost ghostly shells of gas expanding outwards. Each one of those shells is like a cosmic smoke ring, a remnant from a past explosion. It's like a historical record, proving this thing has been going off every 80 years or so for a long, long time. And that 80-year cycle means that for most of us, this is a genuine once-in-a-lifetime opportunity. I mean, think about it. You might get to see a few total solar eclipses in your life, if you're lucky and you travel. But this is an appointment with the cosmos that you are not going to get a second chance to keep. Okay, so you've got the science down, but let's talk about the main event, right? What are you actually going to see when you look up at the night sky? Yeah, this is the big question. We're talking about a thermonuclear explosion on the surface of a star. Is this going to be some dazzling fireball that completely changes the night sky? Well, the reality is a little more subtle than that. It's not going to be something that, grabs your attention while you're walking down a city street. Instead, what you'll see is what looks like a new star has suddenly appeared in that Northern Crown constellation, and it'll be shining about as brightly as the North Star. And here's a fun fact that really helps put that in perspective. A lot of people think the North Star is like the brightest star in the sky. It's not. Not even close. It's not in the top 10 or even the top 40. The North Star is the 49th brightest star. So that's the level of brightness we're talking about for this nova. Pretty cool, but not blinding. So you might be thinking, if it's not a huge visual spectacle, why is everyone so excited? Well, for scientists, this is a huge deal. The last time this thing went off was back in the 1940s, long before we had modern space telescopes like Hubble or James Webb. This time, an entire arsenal of instruments is going to be trained on it. This is going to be the most studied nova in history, giving us a front row seat to this crazy cosmic recycling program. Now, it's really, really important we make a distinction here. You've almost definitely heard of a supernova, and you might be wondering if that's what this is. Let's clear that up right now. Okay, so a nova, the thing we're seeing, is a surface explosion. The white dwarf at the center, it survives. The whole cycle just repeats. A supernova, on the other hand, is the catastrophic death of the entire star. It collapses and is completely obliterated. And the difference in brightness, it's just staggering. A nova gets as bright as a prominent star. A supernova can briefly outshine its entire home galaxy. We're talking two completely different scales of destruction. And that brings us to the final and maybe most important point. We are perfectly safe. At 2,600 light-years away, this nova poses absolutely zero threat to us here on Earth. So you can sleep easy knowing this cosmic fireworks show is just for our viewing pleasure. So as you get ready to go out and look up for that new star, just remember what you're really seeing. It's not a birth. It's more like a recurring, violent cosmic hiccup in a dance between two ancient stars. And it kind of makes you wonder, doesn't it? If a nova is just a stellar hiccup and a supernova is a star's death cry, what other incredible dramas are playing out in all the quiet corners of our night sky, just waiting for their light to finally reach us?